Hey guys, hopefully nothing too scary in this one. We're just going to be looking at solving some linear inequalities. We'll be writing our answers in normal form and in set notation, just so we get used to that. And there is a subtlety in here that I'm going to go over and explain, and that is when we divide inequalities by a negative number, the direction of the sign changes. So we're going to look at that too. Okay, let's get cracking. So, first up, 5x minus 2 is less than or equal to 3x plus 4. Now you solve inequalities pretty much in exactly the same way as you solve equations. So, we want to end up with an x on its own on one side and a number on the other side. So, I think the first thing I would do is take away this 3x. So it's positive, so we're going to subtract it. So 5x minus 3x gives us 2x. Nothing happens to this minus 2. So 2x minus 2 is less than or equal to 4. Then I'm going to sort out this minus 2. So we add 2. So we get 2x is less than or equal to 6. And then finally we divide by 2. And we get left with x is less than or equal to 3. Now if we want to write that in set notation, we would say x is such that x is less than or equal to 3. Like that. Good times. Example 2. 7x plus 1 is greater than 4x minus 3. So, my first move would be to move the 4x. So we're going to subtract 4x. So we get 3x plus 1 is greater than minus 3. I'm then going to sort out this plus 1. So we're going to subtract it and get 3x is greater than minus 4. And then finally, we need to sort out the 3. So divide him away, we're going to get x is greater than minus 4 thirds. Or in set notation, x is such that x is greater than minus 4 thirds. Okay, 9 minus 2x is greater than x plus 5. So, first thing I would do here is sort out the minus 2x. So we're going to add that to both sides. So we're going to get 9 is greater than 3x plus 5. Take away the 5. So 4 is greater than 3x. And then finally divide by 3. So we get 4 thirds is greater than x, or x is less than 4 thirds. Or in set notation, x is such that x is less than 4 thirds. Good times. Okay, next example. 5 lots of 2x plus 1 is greater than 7. Expand the brackets. 10x plus 5 is greater than 7. take away the 5, so 10x is greater than 2, divide by 10, x then is greater than 1/5. Oh, in set, x is such that x is greater than 1/5. Good times. Okay, hopefully you're alright with all of these so far then. So now I want to talk briefly about what I mentioned at the start, when we flip or change the direction of the inequality sign. So, hopefully everybody out there agrees with me that -2 is less than, let's go, 6. Yeah? -2 is definitely less than the 6. Now, what happens if I divide both sides of this by -1? So, I am going to divide this side by -1, and I'm going to divide this side by -1. What's going to happen? Well, -2 divided by -1 would leave us with +2. So we've got +2, and then 6 divided by -1, well, that would give us -6. Now, is +2 less than -6? No, it's not. So, when we divide inequalities by a negative, you have to flip the direction of the inequality sign. Otherwise, it all goes Pete Tom. So, let's get rid of that. Get rid of that. Change the direction of our sign. 2 is greater than -6. So, there is absolutely no reason why we would come across an inequality exactly like this. I just use numbers without algebra to demonstrate where the problem comes from. Now we'll have a look at problems where we have algebra involved too. Okay, so 5 minus 2x is less than 10. So let's start by moving the 5. To do that, we're going to subtract it. So we would get minus 2x is less than 5. Now, we need to get rid of that -2. So, it's important here as well, I should say, we could add 2x to both sides, and then we would have the x term and the number term on the same side, take away the constant, and solve it that way, but it's quicker just to divide the negative away. So, be very careful. We are dividing by -2. So, straight away, I'm going to change the direction of my sign. So now we've got x is greater than 5 divided by -2. Now 5 divided by -2 gives us x is greater than -5 halves, or in set, x is such that x is greater than -5 halves. Good times. Okay, then we've got 7 minus 2x is less than or equal to 4 minus 3x. So, when we have an equation or inequality with x's on both sides, I like to get all of my x's together first of all. So, I would add 2x. So we get 7 is less than or equal to 4 minus 1x. So 4 minus x. Then if we subtract the 4, the 3 is less than or equal to minus x. So minus x is saying minus 1x. So we're now dividing by minus 1. So the sign is going to change direction. 3 divided by minus 1 is minus 3. So we get minus 3 is greater than or equal to x, or x is less than or equal to minus 3, and set x is such that x is less than or equal to minus 3. Good times. Okay, final question for this video. We'll do more of these in part 2. So 6 minus 5x over 2 is less than 4 minus 7x over 3. So we've got fractions involved. So there's quite a few different ways we could attack this. I would just multiply through by the base of each fraction separately. So if we first of all multiply through by 2, we get 6 minus 5x is less than 2 lots of 4 minus 7x over 3, and then multiply both sides by the 3. So we get 3 lots of 6 minus 5x is less than 2 lots of 4 minus 7x. So we got rid of the fractions. Now we just expand. So 3 lots of 6 is 18. 3 lots of minus 5 is minus 15. So on the left we've got 18 minus 15. X is less than 8 minus 14 x, like that. Okay, so now I'm gonna add 15x to both sides, so 18 is less than 8 plus x. Take away the 8, we get 10 is less than x, or x is greater than 10. Inset x is such that x is greater than 10. Cool. Okay guys, that will do for part 1. We'll get on to even trickier questions in part 2.